All right, welcome to Module 8, Part 3. And so now we're going to talk oil refining works and their numbers. So we have chemical processes, and we're going to talk cracking, unification, and alteration. And to make it really simple, you need to know these three terms and what they each mean. It means that I'm taking a petroleum hydrocarbon chain in its processing method, and I can either break up the hydrocarbon chain into smaller pieces when I'm playing with crude oil. I can take those tiny pieces and reunify them, so put them back together. And then finally, I can rearrange the actual chain itself so that it's redesigned into my needs. And you watched the videos, so you saw these. And so I can just break it down into simple layers. So cracking, one of the forms of cracking is thermal cracking. And I can do high heat cracking by doing three different things. I can steam it, I can visa-break it, or I can coke it. And we've already talked about coking when we talked about coal. The other way that I can use cracking is to do it with a catalyst. So I can agitate the system to make it break apart. And I can do this through chemical alteration. Next form was unification. The unification process of hydrocarbons, sorry, I'm getting tongue-tied, can be done through catalyst. And so I will take a catalyst and it will allow me to recombine it into new structures. And finally, alteration, where I'm taking it and I'm rearranging the material. Now, one of the things that we haven't talked about is that when we're using crude oil and we're actually refining it down, first off, oil refineries are up and down the U.S. coastlines. They are just all along the coast, and we refine them. One of the nearest places that you will find, well, there's some in New Jersey. So depending on what part of Westchester you're living in, if you're in Westchester, there's some right there. And then there's a whole slew of them right up in New Haven, Connecticut. And so depending on what part of Westchester you're living in, you're within 40 miles of one and 40 miles of the other. But either way, they are up and down the coastline, and they look kind of like big oil tanking systems, or they look like bubble structures. Now, the crude oils that we are refining are all tailored setup. We don't waste anything when we're refining crude oil. Extraction process can be pretty sloppy, and the use process, when we're finally using it, is a pretty sloppy process where we create a lot of pollutions and a lot of byproduct. But when it comes to the actual refining, where I'm taking crude oil and I'm refining it down to the materials that I need, I'm using almost everything. It is a highly used substance in every bit and piece, including leftover coking material, which then I'll use as catalysts in the refining process again. The tank structure and the way that the tank is set up and the material that we're using in the tank is all tailored to the crude oil. And the crude oil itself is also all tailored up to the point of, if I was to take a sample of crude oil and take out all the particulates and actually test it, I can test that crude oil and I can actually point to a part of the world and say, this oil came from the Middle East. This oil specifically came from this one particular well. And that is because while the oil was forming in the earth rock layers, they have different contaminants and materials from the rock and material around it that allows me to actually pinpoint its location and things, which means that when I'm doing a crude oil process, I'm tailoring it to actually boil down and burn down and break down oil for that specific part of the world, which also means that a refinery has to be reconfigured if we were to take oil from a different part of the world all of a sudden, and that takes time. And so these things are all highly tailored, very specific, and they also do not create a lot of waste in the process of making crude oils. You guys had watched the video, so you've already seen this lovely refining process, but they're basically showing you the stuff that comes out at warmer temperatures versus the things that come out at cooler temperatures as they work their way up the line, and then the different cracking, coking, alkylation processes and reforming processes that come off of crude oil. Here is the books version, and I'm sorry, it's not very good. The books version is not as good as the color version pulled off the web. So some of the stuff that we make with oil, petroleum is such an important product. And while we pick on it for its gas use. It is really important. And one of the most important uses of petroleum that we don't talk about often enough is plastics, and specifically medical plastics. We like the idea of being alive, right? We like to live. And so to do that, we need plastics. We need these materials. And so in some ways, if there's something to save petroleums for, it would be for human medical advancement. And plastic is an important wonder tool in this world. And so as much as we pick on petroleum, we pick on fossil fuels. And I agree that in some forms, fossil fuels is a very big waste in this world. There are some really important uses for petroleum, and it does have a place. So even in our clean, green future, we're never going to get rid of it altogether. What we will do is we'll find or use fossil fuels for the truly important things, or at least that's what I like to think. I like to think positively. I like to think that my glass is half full, and then we're going to move to a cleaner, greener future, and petroleum will be used appropriately in the advancement of human well-being, right? So that's just me. So getting into some of these petroleum uses, we use some of that crude oil material as solvents. They go into paint thinners, lacquers, inks, cleaner materials. They're in there. And so that's one of the forms. Another one is in lubricating oils and greases. And then another one is paraffin wax. Paraffin wax is a byproduct of petroleum. It's also a byproduct of oils and fats, but I can get it out of petroleum as well. It's one of those chemical signatures that I can pick up in petroleums. Another one is Vaseline, so petroleum jellies, but we also use in toiletries and medical products as well. Asphalt is another petroleum product, roofing materials, flooring covers, so on and so forth. And then plastics, synthetic rubbers, packaging, casting, fabrics, bubble gums, so on and so forth, right? Some of the desirable qualities of plastic is that it can be made lightweight. It can be very heavy. It can be made weak or strong based on need. It can be molded into any shape conceivable. Are excellent insulator materials, have various forms, ranges. They can be strong, they can be brittle, they can be elastic. I can use them as a waterproofing material because they are hydrophobic. And so it's got its versatility and it has its importance. And I just want to put that out there so that every time we pick on fossil fuels, I do want to just preface and say that it has its place. As far as oil reserves, and you've already done the numbers way back in Module 1, and you'll continue to do the module numbers for this unit as well. There are reserves all over the world, and while we like to think of the U.S. as having oil, it doesn't even fall into having its own bubble on this list of oil reserves in the world. As far as how long it lasts, well, that depends on how quickly we go through the reserves. And whether we will find ways to extract the harder to get at oil. So it's not about finding new reserves. We know where the oil is in the world. The key is developing the technology that will allow us to get at that oil. For example, we know that there's a bunch of tar sands all over the world, but the price needs to be right and the technology needs to be good enough to get at those tar sands to continue to utilize it. Already did the numbers, and we know from doing the math prior to, the approximate calculations is that we're going to get another good 45 years of oil use if we choose to continue using it at the same path and rate that we have been. As far as burning gasoline in cars and trucks and what it's producing in pollutions. And these are going into not just the fossil fuel chapter in your text, but the next chapters after talking about pollution products. We can see that it's producing a lot of CO2, hydrocarbons, nitrous oxide, sulfur dioxide, and actual solid particulates. There's a lot of environmental concerns, and there's an entire future out there at stake if we continue moving in the direction that we're moving. And so there's a lot more to be said on that regard. And so I will pick you up with a quick part 4, and then we'll be all done with mine.